Okay, here we go. Three new formulas today. 4 problems for your assignment. 4 problems for your assignment. What we want to do is we want to reduce our powers. So for example, if you have sine squared of x, we want to make that look like an expression that does not have a squared in it. Okay? And it's really not too bad. You don't have to write this down, but I'll show you. We learned the other day that cosine of 2x was equal to 1 minus 2 sine squared of x, right? Remember that? Well, if I subtract 1, cosine of 2x minus 1 is equal to negative 2 sine squared of x. If I divide by negative 2, I get 1 minus cosine of 2x over 2, right? That's all you have to do. So you get 1 minus cosine of 2x divided by 2. That's what we call your power reducing formula. Now, why is that helpful? Well, again, this course is pre-calculus. I need to teach you things that you'll eventually use in calculus someday. So if you were given the integral from 0 to pi over 2 of sine squared of x dx, that's a very difficult problem to do. In fact, I don't really know where to start. All I know how to do is this. Go from 0 to pi over 2, and instead I'll insert 1 minus cosine of 2x over 2 dx. Now, the fact is that as Megan looks at this, Megan would know that if she saw us right now, she would not know how to take this antiderivative, would you? No. But this one, you know how to do substitution, right? If we say that u is equal to 2x, then du would be equal to 2 dx, right? And we can find our antiderivative. This is super challenging. My point is this. When you guys get to calculus, this will be useful to you. But if we have to spend all the time talking about our trigonometric formulas again, that doesn't work. So this is your kind of introduction to these power reducing pieces, and you will use them. Okay, so cosine squared of x is equal to 1 plus cosine of 2x divided by 2. And tangent squared of x is equal to 1 minus cosine of 2x divided by 1 plus cosine of 2x. Those are 3 power reducing formulas. I take it from a second degree down to a first degree, which is much easier to deal with in calculus. And we're going to try rewriting some expressions here today. Please go ahead. They're all cosine because, remember your cosine formula for a double angle? Or cosine for a double angle had 3 formulas with it? Yeah, so we use that to derive these pieces. Notice that all these expressions have a cosine in it, and all these expressions have a double angle in them as well. Okay, so they come from the double angle formulas that we went through yesterday. So let's do our 2 examples. Rewrite the following expressions in terms of first power cosine. So I should have a cosine in my answer, and I should have first power, no second powers. Okay, no third, fourth powers, all first powers. This is a big spot on the test where people write that. Don't write that. You right? What is it? Oh. I got it. Leave me alone. Okay, well, the Greek language has about 4 different accents you put on top, so I don't remember what the Spanish. In Spanish, just 1 accent symbol. 2? Okay, all right. Trust me, My Greek courses were harder than my math courses. So here we go. Sine squared. What am I going to put in for that? Well, we're not going to solve because there's no equal sign, but we're going to simplify. And as we multiply, your 1 times 1 is 1. You notice these are, they're conjugates, so the middles are going to cancel, correct? Does everybody see that the middles are going to cancel? Cosine squared of 2x all over 4. You're right, so we're not done. So this is where we arrive at an issue that we have to work through. So what we have is we have a new formula we need to create. I know that cosine squared of x is 1 plus cosine of 2x over 2. What happened to the angle as I went from the first expression to the second expression? What happened to the angle? It doubled. So if you wonder how we rewrite cosine squared of 2x, again, we double the angle. So it will be 1 plus cosine of 4x over 2. So I have to double the angle. So now I know what to put in for cosine squared of 2x. Got 1 minus 1 plus cosine of 4x over 2 all over 4. Now what? Common denominators. Terry, the voice of reason. Thank you. I'm going to distribute that subtraction sign all the way through. So I have 2 minus 1 minus the cosine of 4x. What's my new denominator? 2 all over 4 over 1. What can we combine? 2 and negative 1 make 1. Multiply by the reciprocal. And what do you get for a new denominator? Starts with an A. 8. It's just a joke. Trying to keep things lively. Now, if you want to write it like this, that's fine. If you want to write it as 1/8 times 1 minus cosine of 4x. If you want to write it as 1/8 minus 1/8 times the cosine of 4x, any of these options are the same, okay? Everybody good? How we doing? Awesome. Okay, so let's do another one. Sine to the 4th. Now what? Very good. B. Rhodey sees it. Sine squared of x times sine squared of x. Now we substitute 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. Good. So this time they are not conjugates. So when you multiply them out, you got to count for the middle. The middle is going to be double. Anybody have a question how we came up with that? Which part? Got to talk to me. Otherwise, I'm just moving on. All right. So, if only I had something to put in the place of cosine squared of 2x. We do? Did we make that up on our own? We must be genius mathematicians. Plus 1 plus cosine of 4x over 2 over 4. Slap a 2 underneath everything. So if I multiply this binomial here, top and bottom by 2, I'll then have common denominators in the numerator, correct? So I have 2 minus 4 cosine of 2x plus 1 plus the cosine of 4x all over 2 over 4 over 1. One and what? This guy? I multiplied the top and bottom by 2, so I got 4 of them now. You don't change the 2x. That's just the angle. Okay, what's going to be my new denominator? 8. What can I combine in the numerator? So 3 minus 4 cosine of 2x plus the cosine of 4x. And again, you could write that, you could factor out the 8, write as 1/8. Got all sorts of options. Well, last year we covered more, but we needed to cover some earlier stuff today, so we'll make it up some other day. Yeah. This one? Okay. Let me write this out. That's over 1, right? So I need to find common denominators between the 1 and the 2. So I multiply the top and bottom of this fraction right here by 2. And I get 2 minus 4. And now it has a new denominator of 2. See that? Yes. So we go from cosine squared to this. The angle doubles. So here the angle is 2x, so I got to double the angle. Just double the angle. Okay. You have an assignment. I know you wanted that. 7.3, page 557. 9 and 10 are easy. Those are problems I expect everybody to get. In fact, one of them we did in your assignment together, or in your lesson, your notes together. But 11 and 12 are difficult. In fact, I would expect that if you did 11 and 12, that together they would take an entire page. Or you could use one sheet of paper for both of them. So, so it's going to take up some space, my guess is, all right? So, in fact, I would say that I don't think everybody will actually get 11 and 12. You might have to spend more than 3 minutes on it. This was Bilake's favorite class. Used to be. And now he hates this class. This is terrible. So, not much you can do about that. You guys remember your grades during third quarter were like 99%. Okay, that we're kind of living in, la la land at that point. Okay, it can't stay like that forever. We got to cover the challenging material. So, Lauren, you said you had a question about that?